I'm Carl Wordsworth. I'm the head of the water sector for Tulsa National Engineering Laboratory in East Kilbride. I've worked for them now for 2.5 years. And previous to that, I've had 24 years experience with fluids-related research and development and product development, mainly in the oil and gas and water industry. My current role at the moment is concentrating on the measurement uncertainty of large diameter flow meters for the water industry. Large diameter meters are important to the water industry because they're the main method that's used when the water companies calculate the water balance and also when they report leakage to the UK water regulator. They're also the principal tool that's used when measuring the amount of water that's abstracted from the environment and also the amount of water that's being transported to the cities. From discussions with the UK water companies, we realise that these very large meters themselves are quite limited in number. They only represent a very small percentage of the overall meters that the UK water companies have, but they're very important in that they measure, in one UK company, they measure 25% of the daily water flow through their network, and this equates to nearly 500 million litres of water a day. So you can see that if the meter itself has a small inaccuracy in the readings that it delivers, this could represent very large volumes of water that could be misreported into the water balance. Unlike small flow meters that can be readily taken away from the network and placed into a test calibration facility to recalibrate them, these large diameter meters are often left in the ground for their entire lifetime, which can be up to 25 years. Therefore, it's important for the water industry to get knowledge about these meters and how they perform over time. With the growing impact of climate change, it's been estimated that globally we will only have 60% of the freshwater needs we have by 2030. Therefore, action is required now in order to change the way we treat water, the way we manage it, and the way it is dealt with in the future. Tulsa National Engineering Laboratory have developed a JIP to look at the measurement uncertainty of large diameter flow meters. The aim of this is to try and increase the knowledge of the meter accuracy and therefore help to reduce unaccounted for water and also reduce leakage. The project intends to look at measuring the uncertainty of these large diameter flow meters, how they react with upstream disturbances. We're also looking at how the meters age with time. We're going to be looking at testing a range of differently aged meters. We're also going to be looking at computer modelling to look at how the flow profile within the pipeline itself affects the performance of the meters, and also how extraneous electromagnetic fields affect the performance of the meters as well. The main objective of the project is to help the water companies optimise their network management and also help reduce leakage. We're going to do that by looking at how the large diameter flow meters, how they are affected physically, how the environment affects them, how the installation affects them, and also how they age and how the aging of the meters affects their metering capabilities. All the data that's generated from the project will be placed into a design guide, and it's hoped that the global water industry will be able to use this as a design guide in order to help them when they install and decide which new meters should be tested and installed into the ground. We're currently in the process of signing up companies to join the joint industry project, so if this project is of interest to you, please don't hesitate to contact me.